Man, I tell you, man, Microsoft has gotten the title, okay, with well-deserved aspects of that too. That Microsoft just does whatever it wants, and I'm talking about not Microsoft the company. I'm talking about Microsoft the products. Okay, I literally before starting this video clicked on this tab here, and it literally disappeared. Okay, the whole section. This was like gone. Like, and I was like, that's impossible. I just clicked on it, and nowhere to be found. Okay, I didn't close. Okay, OneNote. I just came back to it as far as I was watching Futurama and decided to make this video and came back to this and rips right there. Okay, wow. All right, so now what we're going to talk about as far as RIP is concerned, as a means, as a lesson of using a dynamic routing protocol. Okay, meaning that we're going to learn routes from the routing protocol as the routing protocol does its job. Okay, and RIP is a distant vector protocol that uses the method of hops as a means of distance. Okay, all right. Its conversions is it's slower than other routing protocols. Okay, all right. And what is convergence? Convergence is the concept of learning the routes from its neighbor. Okay, all right, and propagating those routes throughout your entire domain. Okay, meaning that this might be router 1 here, okay, but as we are configuring RIP, it might take a couple minutes before router 1 can reach all the routers and all the routes that are being advertised by RIP as a means of we are finally balanced, everyone's reachable, we're finally converged. Okay, all right, it is the completion of the process. All right, so now let us go over to here. All right, bring this window up so I can see it. Okay, and I'm sure this stuff is gone because I don't think I saved it. Okay, so it is gone. All right, and let's see. Okay, and that's there. Okay, so now let's take a look at our writing table. Okay. Okay, so we're going to remove that. All right, and alright, so that's gone. Okay, so there's no default route, and my ability to ping is gone. And same here. Okay, because we removed the actual default route, alright? Or static route, however you want to look at it. Now, let's configure RIP. Okay, now let's actually look at our question mark or our syntax and read the description. Sometimes these descriptions of the commands are vague. Sometimes they're very helpful. Okay, I can't tell you how many times I've actually used a command and never used it before just by reading the description. Okay, so to go into our router process to make configurations, this is the command that we will use. Enable a routing process. Okay, makes sense, right? And what routing process can we do? BGP is one of them. EIGRP is one of them. Okay, both of those we're going to discuss later on, not in this video. Okay, ISIS is one that we're not going to discuss. Okay, and you know what's funny? I might go through that myself. And maybe do some simple stuff on as far as training perspective, but it's a protocol I've never used in my 15 years. Not saying that's not going to happen, because ISIS is something that is used heavily in a if you're going to use it in a ISP and a Nexus topology. Now, Lisp we're not going to use. ODR. Oh my God, I totally forgot about ODR. That is something that we're going to do. We'll cover, and again, not in this video. ODR is pretty cool. All right. And it's been a while since because I've never done it at work. I've never seen it deploy in a production network in my career. But I've definitely, at one point, was really good with it from a learning perspective. But, I mean, you don't use it, you lose it, right? OSPF, which is what we're going to cover, and RIP, we're going to use as an example, but not actually go through the routing protocol as a in-depth aspect. Okay, so BGP, EIGRP, OSPF is going to be our main focuses. All right, so router RIP. Okay, and keep in mind this is just the beginning. I'm just showing you how a routing protocol works. All right. Okay, now in the routing process, because as you see, our command prompt now says configure router. All right. The first command that we're going to do is network. Enable routing on an IP network. Okay. All right. Again, it's kind of vague, but it kind of makes sense, right? We are going to enable it. All right. So first of all, network. Now here's the thing with RIP. Okay. I'm only telling you this from a perspective of you understanding why I'm putting the command in there. All right, so 192.168.1.0. Okay, now, RIP uses the default class aspect of that routing protocol in the network statement. So, the first three are going to be 255s in the subnet mask, right, as a default subnet mask for the 192 address. So that's what I'm going to type in, right? Now, for the one network, which will be the 1.1.1.1/32, I'm going to write it like this because the default subnet mask is 255.0.0.0. Okay, and now RIP is enabled. Okay, do show run include router. No do needed. Now let's do another command and start include. Let's do section. Okay, that'll give us all of it. So that's it. That's what we need. Okay. Now router 2 is not going to get updates until. All right. Now you also going to understand what this network statement does. What this does is for any interface that has a 1 dot whatever on it, turn on RIP and advertise that network of that interface. Okay? So, now, okay, now RIP has different versions, and we're not going to go into that. Okay? I'm just going to show you what a routing protocol does. Alright, network 192.168.1.0 and network 2.0.0.0. Okay? Now, they're both enabled. So now, okay, these two routers can communicate via RIP. And look at here. We got a RIP route. Okay? Look at that. And it even gives us a 2.2.2.2 that is directly connected, but a one network. Okay? Now, okay, I can ping 1.1.1.1. Bingo. Because in that show IP route 1.1.1.1, okay, look, this route of a /8 is known via the distance of, is known via RIP with a different distance of 120. Okay, and there it is. Here's my administrative distance. Here's my metric. Okay? Why is it 1? Because it's 1 hop away. Alright? Okay? So, that's a routing protocol. Now, imagine putting router rip, just those couple commands on every one of these particular routers, and just wait a couple minutes, and we are fully converged. Now, router 1 knows every route in the network. Okay? And can reach every one of them. Tell me that that's not so much easier, okay, than doing static routes. Okay? Alright? And that's pretty much it. That's the power of a routing protocol. So be strong, be determined, be Cisco.